I'm going to give a walkthrough of the Bud Inference Engine dashboard, which helps you manage your deployments, create new ones, monitor progress, and access many other functionalities. I'll start by logging into one of my accounts. Once logged in, I have different options within the system, like projects, models, dashboard, etc. We have a model registry that allows you to manage all the models that are supported or allowed to be deployed within your system. You can onboard models from Hugging Face, cloud providers, and more. The system doesn't just allow you to deploy open source models, it also supports deploying management entry points for your cloud models like OpenAI, Claude, and others. So you can think of this as a single entry point or a unified management system for all your Gen AI workloads. From here, you can add different types of models, cloud models, Hugging Face models, models from a URL like S3 or blob storage, or even load from your local disk if you have a pre-trained or fine-tuned model that you've created yourself. Let's say you start with a cloud provider. You can choose any available provider, and then you'll get a list of models from that provider. You can select the model you want, give it a name, choose its modality, and optionally add tags to help you recognize or filter it later. Similarly, when adding a Hugging Face model, you can enter the model name, sample URL, author name if needed, and tags for easier identification later. In this way, you can onboard as many models into your system as you want to use or experiment with. Once a model is added, the system automatically fetches some public metadata, like tags, strengths, use cases, etc., based on available information. It also pulls in some technical details for your reference. This will be available automatically so that you can understand the different use cases. As a user, you onboard, and when someone else is using it, they may want to understand what the model can be used for. This way you can use the information to evaluate the model as well. Now, once we have the model, we also have a cluster. This is more of a management dashboard that allows you to add multiple clusters to your system. Let's say you have a cluster on-prem and another in the cloud on AWS or Azure. Similarly, you might have a Gaudi cluster, a GPU cluster, or a Xeon cluster. You can add any number of clusters, and different deployments can be done on different types of clusters. For adding a cluster, we currently support Kubernetes and OpenShift clusters. You can create your cluster and add the configuration file. If you have a name for the cluster, you can onboard it using that. Once onboarded, we will perform the necessary installation on the clusters to enable the system to be optimized and deployed for all the different runtimes available. Now, if you go to the project section, it's more like a team space where you can manage your deployments. You can create a project for a specific number of people within a team or department, etc. That's how you can manage it. Once you create a project, you can deploy a model within it. Let's say you want to deploy a model, you go to Deploy Model and choose one from the list. For example, I'm selecting Pi here. When deploying the model, you're doing so for a specific use case, such as chat, RAG, code generation, etc. These are different types of use cases. These use cases are important because performance metrics vary depending on the specific use case, and your input-output token combination also changes accordingly. When deploying, it's ideal to optimize the deployment specifically for the chosen use case. Otherwise, you won't be utilizing the appropriate hardware at that point in time. That's why optimization is crucial. To support this, we provide an option to select a deployment template. Once you choose a template, the system automatically fills in certain details, such as context length, sequence length, TTFT, time to first token, end-to-end latency, and more. You can also adjust these values as needed. If you want to increase or decrease them based on your performance targets, you can configure them accordingly. You can also assign a name to your deployment, which can then be accessed via API or integrated later on. For this example, I'm setting a concurrency of 10 requests. Next, I click Next. At this point, the system identifies the best cluster or hardware available. Earlier, we added a few clusters in the clusters section. The system runs a simulation across all available clusters to determine the most suitable hardware for the specific deployment, taking into account the performance targets, input-output configuration, and the model itself. It then provides a list of recommended clusters along with simulated performance metrics and expected cost per million tokens. This information helps you choose the most efficient option, whether it's the recommended one or any other cluster from the list. Once finalized, you can select a cluster and click Next to deploy. That completes the deployment process. Essentially, we are automating the entire workflow to ensure the deployment is optimized for the available system hardware. After deployment, you'll see a list of your deployments. If you want to integrate the model, there's an option to access a sample URL or code snippet, which helps with integration into your system. The URL or integration point remains consistent across all deployments. You just need to update the model name and use the correct API key for your project. To create an API key, go to the API key section. Here, you can generate a key for each project. Each project requires a separate API key, and you can create multiple keys per project. You can also set expiry dates. This is useful if you want to share your endpoint for a specific event, time-limited usage, development, or for other use cases. Simply create the key and share it as needed. Now let's look at the dashboard section. It provides analytics on system performance, such as the number of requests served, number of endpoints, cluster details, latency distribution, flop utilization, and API call counts. It gives you a high-level overview of the system's operational metrics and usage statistics. That's a summary of the inference engine and the various options available in the system.